It is clear that once there is even a small amount of raw material, the simple physics of the universe will give rise to a planet. Planetary systems like our own begin their lives as diffuse clouds of hydrogen, helium, and a smattering of heavier elements. When these clouds collapse to form a system, most of the material in each of these fragments coalesces towards the center, where friction heats it to high temperatures, becoming a protostar, a star that has not yet ignited fusion in its core. The material eventually forms a flat plane around the protostar, the beginnings of a protoplanetary disk. The vast majority of the disk is made of hydrogen and helium, but sprinkled throughout the swirling chaos is dust. Microscopic grains of heavier, more complex molecules. Just like the dust that clings irritatingly to the surfaces of your home, the dust in a protoplanetary disk sticks together. Finding each other in the spinning sea of lighter gases, the dust begins to clump, molecule by molecule. Over the span of hundreds of thousands of years, these clumps become large enough, roughly 100 meters or so, to completely change the fate of the disk. At roughly this size, the clumps, now known as planetesimals, have a gravitational pull of their own, which they use to inflate their size by attracting new material. Within the inner regions of the disk, near the young star, which has finally begun fusing hydrogen, the heat is too much for light elements like hydrogen and helium to remain, and too much for volatile elements, like water and carbon dioxide, to stay a solid ISIS. Only the heavier elements, like iron, carbon, and silicon, and their molecular combinations, can survive here. The inner regions of a solar system therefore become the home of terrestrial worlds, and the outer regions form the larger, gaseous worlds, this process repeating generation after generation, star after star across the nearly countless billions, fills each and every galaxy with a population of planets. So with this picture in mind, it seems that heavy elements are a prerequisite for building planets. And even though planets are numerous, they are small. The Earth or Jupiter or any exoplanet may seem enormous to human scales, but they represent mere rounding errors in the cosmic accounting of elements. It is clear that once there is even a small amount of raw material, the simple physics of the universe will give rise to a planet. But how long did it take for the cosmos to generate enough raw material